The hard part of dealing with systems of inequalities is always going to be our application problems. We're going to attack this application problem in the same fashion that we attack the application problems for systems of equations. Your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must be sold? Well, first of all, there are two types of seat. There's balcony seats and orchestra seats. So my two variables, we'll just call them X and Y. So X we'll call the number of balcony seats that we sell, and we'll call Y the number of orchestra seats. Now, one of the things they told me is that I need to raise at least $30,000. At least means greater than or equal to. So I know that $20 times the number of balcony seats plus $30 times the number of orchestra seats has to be at least $30,000. The other piece of information that I have is that the center has 500 orchestra seats. That means that that's the highest amount of orchestra seats we can sell. But that's the only other piece of information that they give me. So the orchestra seats, which is Y, has to be less than or equal to 500. So this is my system of inequalities. Now, when we graph the real world problems, it's probably best to create our own coordinate plane instead of using the general coordinate plane. That's because we normally graph real world situations in the first quadrant. Now, one of the things I want you to notice is that the inequality Y is less than or equal to 500. That means that it's a horizontal line through 500 on the y-axis. Well, where's 500 going to be? Well, maybe we'll do 1, 2, 3, 4. We'll call this 500. So I have a horizontal line through this. Let me try to make that look a little bit better. And the shading for it is going to be below the line. For the other inequality, I can do the X and Y intercepts again. That's usually the easiest way to graph this. The textbook printout, it uses slope-intercept form, but I don't think that's the best way to do it. So the x-intercept, where y equals 0, is going to be 20x is equal to 30,000. So x is going to equal 1,500. The y-intercept, where x is equal to 0, is going to be 30y is equal to 30,000. So y is equal to 1,000. So I already drew this to 5. Let's make this look nicer. To 500. So 6, 7, 8, 9. Here's 1,000 on the y-axis. And then I need, well, if I'm doing hundreds, I need 15, I guess, on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So something to that effect. So there's my line for 20x plus 30y is greater than or equal to 30,000. Greater than means I'm going to shade above the line. Well, where are these two shadings going to overlap? They're going to overlap in this region. Extend that line. So in order to make my at least $30,000 that I want to make, the ordered pair for the number of balcony and orchestra seats has to be any ordered pair that lies inside the shaded region or on the line. So, for example, let's see, if that was 15, 14, let's see, here's 1,300 right here, and maybe 1,300 This looks like it's about 300. So we'll maybe say this is 1,300 and 300. 1,300 balcony seats and 300 orchestra seats. If you plug those numbers in for X and Y into the money equation, you need to make sure that the answer you get is greater than 30,000. So any ordered pair that lies in that region is going to solve this system. Now also, because it's a real-world problem, a lot of times these real-world problems, the answers are in whole numbers. You can't sell a half a balcony seat or a third of an orchestra seat. So you know ahead of time that the answer has to be integers. The other thing is that the numbers can't be negative. So more specifically, our answers have to be whole numbers because whole numbers are positive integers.